Hi everyone, thank you for helping me out with my usability testing report. So let's get started. What is Lux? Lux is actually supposed to be an interactive journey that teaches the user steps to make a light installation. And it's supposed to be designed as an immersive narrative driven environment based off of the design process. So all this you don't actually need to fully understand, but this is what the world looks like. It's a virtual world, and here is your starting point. You need to collect items and play games to in order to proceed and get to the last level. Problem statement is that current learning methods often rely on passive formats such as reading, watching videos, and listening to lectures. What you guys are doing right now. And so these methods may lead to reduced learner engagement, limited knowledge retention, difficulty understanding complex technical concepts. So there's a need for a more interactive and experiential learning approach that encourages active participation and learning by doing. So this learning by doing is done on this arcade machine, which is known as Lumi, developed by my internship company. And Lux, which is the environment game, will be played on this as the platform. And the whole idea of this project and my module is that we want to further develop and further improve this project by including human computer interaction principles and also AI. So, what is the problem when wanting to play a game on this and learn from it? There's actually so many different screens that you have right now, which is a touchscreen, main display, and a top panel. So, there's so many screens how to play. Need to explore the space, but what if you get lost? Because, like what I showed earlier, there's it's actually a room, multiple rooms. And the next problem is if you want to play games on the touchscreen, because that's how they play the games in order to continue to the next level, will they know what to do? And what if they get lost? So we combat those two problems that I mentioned earlier by giving these two solutions, which is one AI guided environmental support, and the other one is called a adaptive touch feedback system. So what it first does is actually it has a trained algorithm to detect the user inactivity, eye tracking involved, and it helps manage sensory overload depending on the user status and helps with the attention management that's going on when you have so many screens to look at. So let's say you're playing the game and you get confused and lost. There's no more input from your hands anymore. So the user will not be having any actions. The system will notice that there's no user input and it will start a countdown timer and the adaptive expression is activated and the eye tracking movement is activated. So it will see whether or not you're looking away or you're looking at the main screen or you're looking down. So we have three scenarios for that. So one is visual, next one is spatial, and next one is haptic. So we use different types of sensories to help bring the user back into playing the game and getting locked in. So let's say the user is looking at the main screen over here, then the AI will detect 15 seconds of inactivity and will determine that it's using the main display to look at. So there will be a visual directional arrow that's activated and also spatial audio. So let's say that you know you are in a room and then you hear something from far away that is like the same kind of sound that we're trying to replicate. So it's like proximity chat, but yeah, you get what I mean. Spatial audio version. Next one is the other spatial audio one, where essentially you're looking away. So he's looking away. He's not even looking at the machine at all because he's confused. So it will use the spatial audio mainly to bring the user back to go and focus on the game. And there will be a touchscreen visual that also appears. The next scenario is haptic. Let's say you're looking down, the user is looking down, but he doesn't actually know what to do. Like he forgot his motor skills. He doesn't know how to use the joystick and the controller again. And so over here, the eye tracking will determine that and essentially use the joystick to make it haptic and also tell them to move to the right with the directional arrow and the spatial audio. So that's it for the first problem. So, okay, for the second idea is that it's mainly AI analyzing the user interaction behavior and tailoring the hints accordingly. So when they're playing the game, we want to make sure that we still have user autonomy and like help promote that they still have to do the thinking by themselves and just providing hints only. So by providing the hints, we essentially analyze the user's interaction behavior, and if they are repeatedly doing all of these things, then we will know that okay, they clearly don't know what they're doing. So in that kind of case, where they are putting the wrong component at the wrong slot, then we will conclude that the user doesn't understand the function of the component. So by doing so, we will show the correct slot that the user is trying to put the component in and tell them why indirectly why it doesn't really work. So we could just say the user is putting this here, but the power outlet component is actually the beginning, the start of the circuit. So it's not supposed to be in this second slot. And then therefore the user will think, okay, where is it supposed to be? It's supposed to be in this slot, the first slot, yes. By themselves, of course. And then next one is the wrong placement. So maybe you could get it right. You could put it in the right order, but it will not necessarily be in the slot. So the AI will help show an animated drag and drop demonstration from wherever the user places it to be, because it knows that, okay, this is technically the correct area, but it's not in the full slot. So yeah, that's all.